Here's an application a lot of people have. They have a sidewalk or a driveway or something like that, and they want to detect, for example, if a car enters the driveway or someone comes in a walkway, they want to be able to detect that and send a signal into their house to let them know, they've got a visitor or whatever. And one of the things you can use is a photoelectric. Here's an Omron photoelectric. This is a retroreflective photoelectric. In other words, it emits a beam of light. It goes out to a reflector, in this case a corner cube reflector. It's reflected back, and then, as you can see here, when I break the beam, there's a relay inside, if you can hear it. There's a double pull, double throw relay that you can use to trigger either an annunciator, a light, or whatever you want. But one of the problems is, for example, in a driveway application, let's say you have the output of this hooked up to a sonalert or some kind of a detector that emits an audible signal, and the car drives in and they break the beam, interrupt the beam, and then that alert will stay on, or that light will stay on, and you really don't want that. You want this thing to just make an announcement that a car is in the drive or whatever, and then stop. So how do you do that? Well, that's the purpose of this project here. It's to develop a circuit that will detect the initial disruption of the beam, send a signal, and after a certain time interval, time out. And then to trigger it again, you have to complete the beam again. So that's going to be this project, and I'll go into the circuit I use next. Here's the circuit I'm going to use for this project. Revolves around a 555 timer. If you look on the internet, there's tons of sites that you can learn about this chip. I'm using it as a monostable, which produces one pulse when it's triggered. It's triggered through pin 2 here. When you take pin 2 low, it'll trigger the output to produce a pulse. So what I'm doing here, I've got a relay here. It says K1. When this is triggered, when this relay is actuated, it closes this contact here. Now when you power this up, this capacitor charges up to plus 12 volts through this 1 meg resistor. And when this relay closes, that's a 470 ohm resistor. When this relay closes, it shorts out this capacitor through this resistor here, through the contact. And that produces a negative pulse, which is connected through to pin 2. When that pin goes negative, it triggers the 555. Now the time constant is controlled by this circuit here. You've got a 500K pot, a 330K resistor, and a 15 microfarad cap. And using those values here, I can adjust the time of the output of this thing from about 7 seconds up to maybe half a minute or so. The formula for this is 1.1 times R times C. So the combined resistance times the capacitance times 1.1 is the time constant that this will output. So when that happens, that output pulse is fed through a 10K resistor to a 2N2222 transistor, and that actuates this relay K2, and the contacts on that relay are used to control an external device such as an alarm or a light or something like that. Now when that output relay is triggered, it also activates an orange LED on the circuit board that I use here, and when you actuate this relay to trigger the 555, it illuminates a blue LED to indicate that you've got an input. Now the reason I have this set up like this is because I want the output here to only trigger once. So for example, if you had this photoelectric across the driveway and a car drove in and broke the beam of the photoelectric, it wouldn't continue to ring an alarm or a light would come on. It would go through one cycle and then stop. To trigger it again, you'd have to complete the beam again and then open the circuit. That way you only get one actuation. If a car or an obstacle stays in front of the photoelectric and blocks it, you're still only going to get one output pulse. So that's basically the circuit that I'm going to be using for this project. So now I'm going to build this circuit on a circuit board and then do some testing, and then we'll move forward to that next step. So stand by for that. I've completed the circuit here on a circuit board, just a piece of perf board here, and it has contacts I can use an edge connector here because I'm going to use this in another project. Anyway, if you look at the circuit board here, here's the 555 timer here. This blue trim pot is the 500K trim pot. It's got a 330K resistor in series with it here. This 15 microfarad tantalum capacitor is here. This capacitor, this 0.01 capacitor, I had a silver mica so I use that. Anyway, that's the 0.01 cap, and then a pacer cap here is the 0.001 cap that couples in. This relay, the green one, is K1. This is the relay that the photoelectric triggers. When you trigger this relay, that activates the 555. This relay, the black one, is this relay here. So when the 555 has an output pulse, it's coupled through a 1K resistor to this transistor. This is the 2N222, and then that triggers this relay, which is this one, and then I've got open contacts here I can use to switch whatever I want, a sonalert or a light or something like that. There's two LEDs on here. There's a blue LED that comes on when the photoelectric triggers K1, this relay, and you've got the orange one that comes on when there's an output pulse from the 555. So I am going to connect this up and test it, and we'll see, make sure that it works properly. And then when I get done with that, I'll hook it up to an actual photoelectric and we'll test it from there. So stand by for that. I have the circuit temporarily plugged into a socket here, an edge connector socket. I've got my voltage is connected. I've got +5, +24, and I've got an input connected here. So what I'm going to do now, I've got a push button switch here, and this switch is going to simulate a photoelectric closure when that contact closes. So if you watch here, now the orange LEDs come on, indicating that the device is triggered, and then it times out. I've got it set at the minimum time here. I think it's about 7 seconds. So I'm going to trigger it again. And as you can see, the blue one comes on as I'm pushing this. This is the photoelectric. Every time that photoelectric triggers, that blue LED comes on and this relay triggers. So what happens if a car goes across the driveway or someone is blocking the path? To simulate that, I got a switch. So let's simulate a car comes in and closes the circuit here. There you can see blue LEDs on, indicating that the beam is blocked, but the unit timed out here. And this is going to stay in this condition as long as the beam is blocked. As long as this relay is activated, you're not going to get an output pulse from the 555. Now I'm going to simulate the car moves or the person moves, whatever. Now the unit's back, ready for the next one. So now, pushing the push button, simulating an activation, you get another pulse, you get an output, this relay's triggered, and then it resets. And once again, if you block the beam, it stays on, it resets, and then it waits until the beam is not blocked, and then it's ready for another cycle. So anyway, that is the operation of the circuit. Next I'll show you how this is going to be used in the actual system that I'm setting up here. I'll do that next. I've mounted the circuit board in this cage. This is out of a piece of equipment I cannibalized, some piece of commercial equipment. I can't even remember what it was, but anyway, it has a number of these edge connectors on it, and it worked pretty good because I can mount these boards in here. I've got another one that I had built here. This is a number of monostables on it also, and that will go in one of these card holders here. But anyway, this cage has 25 cables, 25 conductors that go up to an old computer serial, 25 conductor serial, the DB25 connector, and then I have this breakout board here that I can make the contacts. Here's a retroreflective scanner, photoelectric setup between a retroreflector here and the unit. So when I break the beam, I've got it temporarily connected up to the unit here. So now I'm going to break the beam, and you can see that it triggered, and now it should reset. Now I'll break it again and it triggers. So now if I hold my hand in front of this photoelectric here, you can see the blue lights on. Do it again. It triggers. It'll put one pulse out on the monostable, and then it resets. To get it to retrigger, I'll have to complete the beam and then do it again, and then it triggers. The photoelectric I'm using here, it's an Omron E3JK-R4M1. Now this connector here will be connected up through a 50 conductor telephone cable up to a control panel upstairs. So the signals that I'm getting in this unit here will be sent up to that panel. Now this photoelectric has a pretty limited range. It's only, 12, 15, 20 feet. I can't remember it, but it's not very far. But there's other options. Now here are two units. These are ABT 150 photoelectrics. There's a transmitter, which is, let's see, yeah, this is the transmitter, and this is a receiver. You can separate these up to 150 meters, and they have dual beams in them. So if you have to cover a larger area, you can use these. And these have relays in them that you can use to trigger this circuit that I built here. So you could cover a larger area. And then another option is you can have multiple photoelectrics. You can have a short range unit on here, for instance, by a gate. You can have long range units here, which would watch through a yard or a driveway or whatever. And then you can have, for each one of these photoelectrics, you can have a separate monostable that's triggered. And that's what this board does. I can have up to 9 different photoelectrics connected through this circuit here, and this will plug into one of the cards on the back of this. So anyway, that's just a quick video on a possible system you can build if you want to cover an area with a photoelectric to sense any type of movement. So I hope you enjoyed that, and Thanks for watching, and I'll see you in the next one. Bye for now.